So this is us skipping to lesson 6, and we are going to find the area of composite figures. This is our last lesson for chapter 9, and it's one of my favorites. So we get to take everything that we learned and kind of put it together into this lesson. So the vocabulary that we're talking about in this lesson is a composite figure. And remember, a composite figure is a figure made of two or more two-dimensional figures. So the composite figure shown to the right is made of these two rectangles here. Draw a composite figure made of a rectangle and a right triangle. So a right triangle is going to have a right angle, right? Like that. And let's put a rectangle off of this. So we have to have a longer side and then a shorter side. So something like that. So this is a composite figure. And if we drew it without this line down the center, it would look something like, well, actually, it would look like a trapezoid, wouldn't it? Pools. The dimensions of the city pool are shown. So all of these dimensions here are important. What two-dimensional figures are used to make the shape of the pool? So this is a huge rectangle, and then this entrance area is what? A trapezoid? So we have a rectangle and a trapezoid. So how could we find the area of this? What if we know how to find the area of this rectangle, and we could add this area of the trapezoid. So if we did the area of the rectangle plus the area of the trapezoid, it would be the area of the pool floor. So that's how we're going to find the area of composite figures. We're going to break it down into the shapes we know and then add all of those areas together. Now, flipping the page, that's what we'll practice here in the first part. And in the second part, we're going to find the area of overlapping figures. So when these overlap, what do we do to find the area? Okay, let's get started. So it says, you can decompose some trapezoids, and decompose, that means to break apart. You can decompose some trapezoids into a square and a triangle to find the area. So in this trapezoid, you have the area of a square, length times width, which is 3 times 3, that would be 9. And then you've got this triangle here, half of the base, so the base is 2 and the height is 3, and that would be 3. Then you could add the area of the square and the area of the triangle to find the area of the whole trapezoid. So the area of the trapezoid would be 9 plus 3, or 12 square units. Now you can find the area of a composite figure using the same strategy. To find the area of a composite figure, separate it into figures with areas you know how to find, then add those areas. So let's write ourselves a little note here. Find the area of composite figures. To find area of composite figures. So 1, we break the composite figure down into basic shapes. Then we find the area of the basic shapes. And finally, we add all of the areas up. So let's practice with this one right here in example 1. Find the area of the figure at the right. The figure can be separated into a rectangle here and a triangle here. Find the area of each. So the area of the rectangle, 6 times 10. Length times width, 10 times 6, that's 60. The area of the triangle, half of the base. Okay, now how do we know that the base is 4 inches? Look at this. This is 10, so this whole thing is 10, and this is 6. 10 take away 6 means this is 4. So 4, and the height is 4. So half times 4 times 4, that's 8. Then we add all the areas up. So 60 plus 8 would be 68 square inches. Oh, this is what told us how to get the base of the triangle. 10, whole thing is 10, take away 6, gave us 4. So find the area of each figure below. Now, let's talk about how to show our work for this. I like to label the different shapes. So this is going to be, let's do the rectangle as area 1. And the triangle is area 2. So for area 1, it's the rectangle, 12 times 4. So area 1 is 12 times 4. So that's 48 square feet. Now, area 2 is this triangle here. So how do we find this? We have half times the base times the height. So we need to find the base. This whole thing is 12. See that? 12 take away 8 would mean this base is 4. So 12 times 4. Now what about this right here? Look at this. This whole thing is 10, and this part is 4 right there. So 10 take away 4 is 6. So this part is 6. So half times 4 times 6. Half of 4 is 2. 2 times 6 is 12. By the way, it should be square feet. So area 1 and area 2, to find the total area of the composite figure, we would need to do 48 plus 12, which would be 60 square feet. So there it is. Let's try this one. How can we break this one down? I see a trapezoid right here. See that? So we have this trapezoid, area 1, plus area 2. So let's find the area of the trapezoid. So area of a trapezoid, half times the height. So what's the height? This whole thing's 10, and this part is 7. So 7 plus 3 would be 10. So we have a height of 3. And then we need the sum of both bases. So 5 plus this base is 7. So that would be half times 3 times 12. Now I'm going to do this mentally. Half of 12 is 6. 6 times 3 is 18. So that's area 1. Area 2 is a little easier because it's just length times width. So this thing right here, 7 times 7, and that's 49 square meters. So now we have to add the two areas. So it's going to be 18 plus 49 equals what? 18 plus 49 is 67, and that's square meters right there. So 67 square meters. So that's how you show your work. You plug in numbers for the formula, and then you show how you add both areas, or sometimes there's more than 2 basic shapes that make up a composite figure. All right, so here's that pool again. Let's actually do it. Example 2. Find the area of the pool's floor. Separate the figure into a rectangle and a trapezoid. So the rectangle was 28 by 14. 28 times 14 is 392. The trapezoid, half times the height. The height was 2. The sum of both bases, 4 plus 6, and that gave us 10. So the area of the pool was 392 plus 10, which is 402 square feet. So now we're going to do this right here. It looks like it's a deck or something like that. All right, how can we divide this guy up? Here's one trapezoid here. What about this trapezoid here? So look, we have 3 parts to our composite figure. So I'm going to call this 1. This is area 2. This is area 3. So let's go. Let's plug it in. Area 1, it's a trapezoid. So we're talking half times the height. Okay, what's the height? We have 36 here, 20 here, 10 here. That makes 30, which means this is 6. Now, base 1 is 14, plus base 2, this right here, is 20. So that's going to be half times 6 times 20 plus 14 is 34. So let's plug that in. Half times 6 times 34. So that first area is 102 feet squared. All right, now let's find the second area. Area 2. This is just a nice little rectangle. So we said this was 20 and this is 20. So it's 20 times 20. So that would be 400, right? Huh, I didn't put a T there. 400 square feet. So that's our second one. Now we need this trapezoid right here. I'm going to do that up here. So the area of that trapezoid, 1/2 times, what's the height? 10 times base 1 and base 2. So 20 plus 14. So that would be 1/2 times 10 times 34. So half times 10 times 34 is 170 square feet. Now we need to add them all up. So 102 plus 400 plus 17. 102 plus 400, or 17, plus 170 equals what? 102 plus 400 plus 170. 672 square feet. Ah, it feels so good when you get that done. All right, now we're kind of switching gears because the next composite figures have overlapping areas. So we need to talk about this. To find the area of overlapping figures, you decompose the figures, but it's important not to count the area of the overlapping portion twice when finding the area of overlapping figures. So what you end up having to do is subtract the overlapping area. So it's kind of like we're going to find the square here, area 1, that's the square. So that'd be 12 times 12, 144. Then area 2 is the rectangle. Well, that would be 15 times 12. But you can't just add those two together because then you'd be double counting this. So when you add those up, 324, you're double counting here. So then you find area 3, that's the overlapping area. Now, they determine that is 6 by 7. So let's see, if this whole thing is 12 and this much is 6, then this much would be 6. If this whole thing is 15, take away this 8, that would be the 7. So 6 times 7 is 42. So what they had to do was they had to subtract that so it wasn't counted twice. So 324 take away 42 is 282. So the key here is to subtract the overlapping figure. All right, we're going to try that together on this one. So we have area 1, area 2, and this area 3 is the overlap that we have to subtract. So area 1, 6 times 8. And we're talking square feet. Area 2, 6 times 7. We're talking square feet. Now area, let's add those up. Area 1 plus area 2. So 8, 9, 10, 90. And what we need to do is we need to subtract the overlapping area. So we need to subtract area 3. What is area 3? Okay, let's figure this out. If this whole thing is 8 right here, this whole thing is 8. Well, wait, this is 2. Let's do this one first. This whole thing is 7. This is 2. So 7 take away 2 This would be 5. So one side is 5. And how do we find this side? We can't use this because it doesn't tell us how much this is, but we can use this. This is 6. Take away 1 is 5. So it's 5 times 5. So this 90 feet of both of the square and the I guess they're both rectangles, is 90 feet. Take away the overlapping equals, so 95, 85, or 90, 80, 70, this would be 65 square feet. So that is the area. Now, see what this one is. Oh, good. It's another example like this. All right, let's do another one here. We've got overlapping figures. Charlie and his brother Matthew are neighbors in an apartment complex. They share the same patio. That's the overlapping area. What is the area of both apartments and the patio? So, if we can find Matt's apartment and we can find Charlie's apartment and we can add those two together but take away this overlapping part, then we should be good to go. So each apartment must have the same 55 by 45, which is 2,475 square feet. So the sum of both of those apartments is 4,950. Now the patio, they said is 23 by 23. Let's see. If you take 55, take away this 32, you'd get 23. And here, this is, we got to use this one, 45, take away the 22, so that'd be 23. So 23 times 23 is this overlapping area. We need to do the total minus the overlapping, and that gave us 4,421 square feet. So let's try some of these in the guided practice. Go ahead and partner up. All right, there are only 2. It sounds like nothing, but these are a lot of work, aren't they? So I want you to find the area for this first one. It's just like our examples 1 and 2. And then check your work. Okay, so the manager of an apartment complex will install new carpeting in a studio apartment. The floor plan is shown at the right. What's the total area that needs to be carpeted? It looks like you need to divide this up into these 3 parts. All right, go ahead and go. So if I was dividing it up into 3 parts, I'd say area 1, area 2, area 3. And to find area 1, it's a trapezoid. So I'm going to do half times the height, which would be this. So we have 25, this part is 12, this part is 8. So 12 plus 8 is 20. 25 take away 20 is 5. So our height is 5. And then our 2 bases. So this base is 10. Plus this base is what? 10 plus 5. So that would be 15. So we have half times 5 times 10 plus 15 is 25. All right, let's get that area. Half times 5 times 25, 62.5 square feet. All right, now let's get area 2. So area 2 is just this little rectangle right here. So we have 12 by 15. So 12 times 15, that is 180 square feet. All right, now let's get area 3. Another trapezoid. So half times the height, which we said was 8, times the sum of both bases, so 10 plus that 15. So that's half times 8 times 25. Half of 8 is 4. 4 times 25 is 100. You can do that one mentally. Now we need to add the 3 areas up. So 62.5 plus 180 plus 100 is what? 62.5 plus 180 plus 100. 342.5 square feet is our answer. 342.5 square feet. See, that takes a chunk of time, doesn't it? Whew. All right, now do number 2. And this is the Finn Fitness Center. It has an entrance to the locker room from both the dance studio and the weight room. So what's the area? Remember, this is just like these composite figure examples 3 and 4. So go ahead and try it. Find the area. Then check your work. So I would say we need to find the weight room, we need to find the dance studio, and we need to take away this overlapping area right here. So the weight room is 30 by 28. So 30 times 28 is 840 square feet. Area 2, the dance studio, 33 by 42. So 33 by 42, 1,386 square feet. All right, now what's the overlapping? Actually, let's add these two together. So 840 plus 1,386 is 2,226. So that is the total. Now we take away this A3. So A3 is, okay, how do we find this out here? This is 28, take away 14. So 28 take away 14 means this leftover is 14. Here, this whole thing is 30. 30 take away 16 would be 14. So area 3 is 14 times 14. 196 square feet. So we need to do 2,226 take away 196. And what does that give us? 2,226 take away 196. 2,030 square feet. And that is our answer. Wow. All right. Takes a while, but it's kind of awesome. So now we're going to try the independent practice on your own. For the independent practice, you're doing 1 through 4. 1, 2, 3, 4. And for number 1 and 2, it's just like example 1 where you're just splitting this up and adding the areas together. So show how you split it up, show how you did each area, and show how you added it together. That's how your work is going to be shown. Number 3 is the same way except look. The floor plan of a kitchen is shown to the right. If the entire kitchen floor is to be tiled, how many square feet are needed? You're going to be subtracting that little trapezoid right there. And then number 4, you've got your overlapping figures. They both teach 6th grade math. They share a storage closet. What's the area? So that's going to be like this down here. Find the different areas, add them up, and then subtract the overlapping. You can do it. All right. Oh, this is a lot of work. So I split this up into a trapezoid and a rectangle. Area 1, 1/2 times the height is 4 times the base 1 plus base 2 is half times 4 times 13.3, which is 26.6 square inches. Area of this rectangle is 8 times 4, which is 32 square inches. Then area 1 plus area 2 gave me 58.6 square inches. Number 2, I have a triangle and a rectangle. So the triangle is half times the base times the height, which is 17.5 square centimeters. And then this rectangle here is 10 times 7 for the area, which is 70 centimeters. And then area 1 plus area 2 is 87.5 square centimeters. For this, number 3, I have area 1 is the square and area 2 is the trapezoid. Or it's not a square, it's a rectangle. So 16 times 12, that's the big rectangle. The little trapezoid, that was kind of hard to find the measurements of this. But you had 16 take away 6 and take away 6. 16 take away 12 gave me this 4 for the base. And then they told me 2 for the other base. And then 1 was the height. So half times 1 times 6 was 3 feet, square feet. And then the rectangle, take away the trapezoid, was 189 square feet. Here, Ms. Friedman's room, 36 times 40 is 1,440 square feet. Mrs. Elliott's room is the same thing. Those two areas together are 2,880 square feet. And then we had to subtract the overlapping area, which was 6 times 6, 36 square feet. This, take away this, gave me 2,844 square feet. Bam. Reflection time. All right, so it says I can find the area of composite figures. First, circle the shapes that are composite figures. Then explain how you would find the area of this figure below using complete sentences. So with words, what would you do? How would you figure out the area of this? You don't have to use numbers at all. So don't do any calculations. Just say what you would do. What would you find first? What would you add together? Then here, show your work down here to find the area of that figure. And then on the back, you have an overlapping figure. So explain how you would find the area of this. Use words. Don't use any numbers. And then show your work to find the area of that figure. Show your work down here. Remember the units. And you're done.